Rebecca because I think I was the person who suggested inviting her. And the reason that is because I'm familiar with Rebecca's work from, for me, it's like the music technology 9 community, and the project that I first learned about is Wakinator. So I thought that given that we're all based in London, she's based in London like us, even though it's a different institution, it would be great to know what she's been up to recently. And I see from the abstract that she continues to work on very, very hot topics, and generative AI seems to be very closely related to what you're telling us about now. It would be great to also know a bit more, maybe after the talk, about how life at a different London institution is and how your work is structured there, and learn more about each other in that sense.
Definitely. Thank you. And definitely, can we, what's that?
Okay, it's okay.
You saying? Okay. Yeah, thanks for the invitation. Hello, hello. Francisca is one of my PhD students that finished long, long ago. Very nice to see you here. Come here. Good to see you. Welcome. Yes, really a pleasure to be here. Anybody who wants to see the slides, feel free to scooch to that side of the room. Right, so I'm not going to give a really traditional research talk today where I talk about one project and we go into depth and I talk about all the research methods and so on. If you have questions about any of that stuff, let me know. Feel free to interrupt with brief questions in the middle. We can be pretty informal. But what I thought would be more fun today than to talk about one project is to give you a little bit of a position paper and a little bit of an overview, and talk about something that's on everybody's minds right now, which is creative machine learning or generative AI, and how that is or might change human creativity. So my talk is called Beyond the Hype: How Machine Learning Can Support Human Creative Practices. And for the last, I would say 10 years, this has been bubbling up in both computer science and in the popular consciousness. And there's been a lot of excitement and hype around generative AI systems. And some of them are pretty cool. I'll talk about some of my favorites. However, the interaction model behind a lot of the tools that are out there feels a little bit to me like the old Microsoft Clippy, where it says, oh, it looks like you're trying to compose a symphony. Would you like me to do it for you? And this has evolved a little bit in the last few years, where it's like, oh, well, maybe type me a text prompt describing the symphony. And then it gives you something. And if you don't like it, maybe you change your text prompt, which is a little bit more interactive than Clippy, and certainly fun and useful for some things. However, it's not really at the core, I would say, of the potential, the power, the excitement of what machine learning could potentially do for people who are doing creative work, whether that's part of their profession or something that might be a thing they do for fun. So questions that I explore in my research and that my collaborators and I often explore together are around, what does machine learning have to offer human creators? How can machine learning support and extend people's creative practices? So I'm not so interested in the question of, can machines create art? Can machines be creative? I think those questions, the answers depend really on how you define art and creativity. I'm much more interested in people and how machine learning might offer them new ways of doing things. And if we unpack this a little bit and we think about machine learning as a set of tools for finding patterns in data, for making predictions in data, and for generating new data, we can just start to ask when and why might it be creatively useful for people to have a machine involved in these processes. And furthermore, how might we enable effective use of machine learning by creators? And so, yeah, usability comes into part of this. Some of it's deeper than that. Some of it's about what kinds of interaction models are we giving. Some of it's about what kind of algorithms are underneath the hood of the systems people are using, and how do we connect people to those. But it's also questions about education, right? What does a person making music or art need to know about machine learning in order to use it effectively with a particular tool? So I'll touch on all of these in my talk. I'm going to start out with a little bit of background. I started working in this area around 2006 when I began my PhD at Princeton. And I got really interested in the fact that there were so many potential sources of data out there that people doing creative work were already working with, or data that they wanted to work with more effectively but struggled to do so. And so at the time, sensors like the Wii, early types of sensors that might be wearables were coming out. Kinect was coming out. Leap Motion came out a bit after that. And of course, these are all still things that people in creative arts, in music, especially in experimental practices, but even in museum and dance and other sort of popular environments, people are interested in sensing data with these things, and maybe sensing how a performer is moving or sensing how a musician is playing. And then there's also, of course, data that you might capture more passively as somebody interacts with something like Photoshop, or as somebody browses through collections of media on their computer. And so increasingly, whether we're talking about accessible, cheap sensors, or whether we're talking about APIs, getting data that's relevant to creative work or performance is often pretty easy, but interpreting and using this data is hard. And that's the case even for expert programmers. And when I started this work in 2006, I was working with a lot of people in the NIME community, which has been mentioned. This is people building new musical instruments out of different kinds of sensors and seeing what kinds of sounds they could make. And a lot of those people had computer science PhDs or electrical engineering PhDs, but we're still really struggling to say, hey, I've got these 20 channels of real-time sensor data coming in. How do I say something useful about what a performer is doing or what kind of sound they want to make? All right, so a lot of the sorts of things I saw creators wanting to do were really about making predictions from data. So in the NIME case, this might be, hey, I've got a camera or sensors, and I see that somebody is moving in a particular way, and I want to decide what sound to play. Or likewise, we could say, I want to predict what sound that person is intending to play. Or we could flip this around and say in a live music performance, I've got some kind of audio coming in, and I want to decide or predict, how might live visuals respond to them, or any number of other things, right? Could be a robot, could be a musical process, something else. This isn't music specific. I also, soon after this work in music, started working with people in the game space, where folks were interested in saying, hey, I want games that respond to movement, but not just the movements I get out of the box with like the Microsoft Kinect API. I want to move in a particular way and have the game do something in response. And these are all things that, can be really, really hard for a person to program, even if they're an expert programmer. But if you know anything about machine learning, you might look at these and say, these are a really nice natural fit for supervised learning, right? Where you have a model whose job it is to look at some kind of input and predict some kind of output. And instead of having a human write all the code for this model function, we could learn this from examples. So we have some training data, maybe examples of movements and sounds, and we're going to train that model using an algorithm. So we just, as a user of machine learning, provide some training examples instead of writing the model code ourselves. All right, so when I started this work in 2006, there weren't really any existing machine learning tools that allowed people to do this kind of supervised learning process in real time, and in the kinds of performance contexts that I was interested in. So I started during my PhD building a piece of software called Wekinator, which is still around and still being used. And I thought, oh, okay, all we need to do is like put some nice GUI on top of supervised learning, and then people can use it, and that's going to be that. I'm going to move on and like find something to do my PhD on. And maybe unsurprisingly, I realized that there was more to it than that, right? To actually make machine learning usable by people who are building new musical instruments, for instance. One of the first things that became really important was this set of training examples. And unlike a textbook machine learning application where you go and you get, you imagine that the training set is somehow like collected for you, or you have a ground truth data set that you can really trust. In this context, I'm making a new musical instrument. There's probably no pre-existing training set. And so one of the first things I want to do as a user is make a training set, and maybe by demonstrating some examples of actions and sounds. And once I've built that model, yeah, I could test it out by computing cross-validation accuracy or any number of other metrics. But what does it even mean if this model is 95% accurate? Like, is that good enough? I don't know. In this kind of performance context, it's much more important and useful for me to actually stick my hands in it, so to say, and try it out and see what it does and see, okay, are those 5% of errors on movements that I'm not going to do in performance anyway, or are they in the absolute most important movements in my piece, right? Because that makes a big difference. So testing out the model in real time was another thing I had to support. And then it became really important and useful to allow people to go back and modify the training examples. So if you say, hey, I've got this model here, and I'm going to move my hand around, and I see that for this particular hand movement, it's getting things wrong. Kind of the most obvious, useful first way to improve that model is to give it more examples of me doing the thing that it got wrong. So Wekinator allows you to do all these things, and this falls under the umbrella of something that was kind of developing into what we would call interactive machine learning in the HCI community. So interactive machine learning means something different historically in machine learning itself, but here I'm talking about an interactive human-in-the-loop process. I'll give you a really quick demo of this because it's fun, and happy to take questions about it later on if you want. But just to show you how easy it can be to use machine learning in this way to do something creative. I've got a little process here. This is capturing a 10 by 10 sort of downsampled grid of pixels, right? So I've got 100 values that I'm capturing from my camera, and I'm going to build a classifier that predicts what kind of sound I'm trying to make based on how I'm standing in front of the camera. So this is 100 values coming in. Even though I consider myself a really good programmer, this is just a pain in the butt to try to write the code to make sense of these pixels and decide what sound to play. But with machine learning, with a very, very, very small number of examples, I can make something pretty accurate pretty easily. And I'm going to connect this to a little bit of sound. It's just coming out of my computer, which is fine for now. You guys can hear that, right? Okay. So I'm going to tell it when I stand here, I want it to make this sound. And I've recorded 11 examples of me standing here. And now I'll record examples of me not standing there. I've got 28 examples total. And now it's working pretty well. And I didn't have to write any code. And now I can start moving around and trying to find a place where it makes a mistake. Okay, so here I would say I still want this to be me. So I'm going to give it more examples and say this is all still sound one. And so I think I've fixed that problem. And I can make it more complicated by saying maybe my hand here is a new sound. And again, I can keep trying to get it to make mistakes and give it more examples. And I would say that works pretty well. So that's the basic flavor of it. That was Wekinator. That was something I built starting in 2008. And like I mentioned, it's still around. People are still using it. And for me as a researcher, this was really transformative. It changed the way I thought about machine learning. I had a computer science background, but suddenly the way I thought about data, the way I thought about the value of machine learning had changed from what I was taught in machine learning classes. So the rest of my talk is just offering some reflections on the path of research that this set me on after my PhD. So that was about 15 years ago. I've had about 100,000 users of my machine learning software since then, probably more than that now. Wekinator's had about 60,000. Francisco worked on a tool with me called RapidMix, which had a bunch of users. InteractML is a tool that I've made with a colleague with about 60,000 users. There's other tools in there as well, including Mimic, which Francisco also helped on. So yeah, I've had a lot of students. I've taught this a lot. And I also am a big fan of a lot of creative work being made with machine learning, both by people using my tools and by people doing unrelated stuff. So the rest of my talk, really, I want to talk about how should we think about machine learning as a tool for supporting creative work? What might this mean for creators? So number one, this is the thing I set out to show in my PhD, and it's kind of the most obvious finding, but it's still super important. I think machine learning can help creators work more effectively with data that they care about. Sensors are hard to work with, but they can be really fun and useful in different contexts if we have the right tools. This is a piece of music by a composer named Anne Heggie. She was one of the first Wekinator users. And this is just an excerpt of a really beautiful piece that she made that uses human motion to control sound. And I'm getting sound just from here, so I'll turn it so you guys can hear it. So I really like this piece, both because I think it's just beautiful and it's a good example of, Anne came to this as a composer with a set of ideas about how she wanted people to move, the movements, the visual quality of that movement, and how that related to sound. And, it was pretty easy to express that through giving examples to machine learning. This is another early art project made with Wekinator. This is an art project where you wear a camera on your head and some special glasses. It's running a classifier and classifying whether there is a screen of any sort in your field of view. And if there's a screen, it makes your glasses opaque so you can't look at it. And this is another just cute example. This is Highbot. You wave at it and it waves back at you. That's all it does. This is made with Elite Motion. So it's just getting hand information here. And I like this. This is something you could make with programming. But it would take you a few hours. This is something that a student in a workshop made in like a few minutes, and it was really easy. And I just love that it's easy to make kind of fun things that maybe are, maybe it's a good use of a few hours. Maybe there's better things to do. So there's a lot more examples of things people have made with Wekinator itself. If you look at YouTube or Vimeo, people have done sort of high fashion shoe instruments. This is Chicks on Speed. People have made digital puppetry. It's been used by a few startups, including, I'm drawing a blank, Baclia on the lower left, a London startup, where you can sing or beatbox into a microphone. It turns that into a track in a music editor. This one, somebody built a thing where you can hold up like a croissant and Google Maps API will take you to Paris, and you hold up an espresso and it'll take you to Milan. So there's like, fun stuff, all because people had an easier time of working with data, right? Okay, now we get into the more controversial, non-obvious things. The second thing I want to get you to think about is how the meaning of data changes in these contexts compared to maybe more conventional machine learning view. So when I took my machine learning courses in university, we thought about data as ground truth, right? Data is this representation of the world, and we assume it might be noisy, right? Not all of it's actually true, but it's kind of the best representation, and it's our way into truth about the world. It's our way into making predictions. And that's fine, but in a lot of these creative contexts, data is more accurately thought about as a way for people to communicate their ideas and their intentions, to say, hey, when I hold up a croissant, this is what I want to have happen. Or when I move my hands like this is what I want to have happen. And this also goes for contemporary generative machine learning techniques that have gotten a lot of attention. So this is an artist I really love. This is Anna Ridler. She's based in London. One of her pieces is called Fall of the House of Usher. And in this piece, she uses an image generation technique where she basically teaches the machine to render stills from a film in the style of her own drawings. So it's been trained on her own drawings. And in her wonderful blog post about this, she writes that the control that comes to me as an artist making this piece, it really comes from what I do with the data set, right? Again, the choice of the machine learning algorithm, yeah, it has some impact. It's going to make it work better or worse, but it's really in the precise, detailed, nuanced pixels that she scans in to the machine learning algorithm that determine what the final result looks like. And there's some interesting implications around this, and something I've been writing and thinking about a lot recently is that there's this emphasis, and there has been for the last 15 years, at least now, around big data, right? Big data fuels all of this really exciting stuff we see in deep learning, especially if we're looking at, LLMs, foundation models for images and so on. However, if we think about data as a way for people to communicate intentions, and machine learning is a set of tools to instantiate those ideas or intentions, then personal bespoke data can be really powerful as well, and we shouldn't overlook it. And in fact, there are many problems with the big deep learning models that have been released by OpenAI and other companies recently. You're probably very familiar with a lot of the criticisms of that, but I want to add another one, which is that big generative models, these things that are trained on, say, millions of data points, don't always capture a useful scope if you think about what they could in principle offer to creators. So this is a representation of some of the training data of OpenAI's Jukebox, which until recently was arguably one of, was the state-of-the-art generative audio music model, right? So it's trained on something like 2 million tracks, and it is trained on quite a wide variety. So you've got a bunch of classical music composers. You've also got country, R&B, Frank Sinatra, the Beach Boys. It's a big scope. However, when you have data at that scope kind of all being digested into the same model, even data that's in this training set somewhere, but which might be more niche in terms of its genre, turns out that that model may not be able to represent and generate that data very faithfully. And in fact, I had a postdoc named Gabriele Vigliansoni a couple of years ago who was in a band that was very popular a couple of decades ago. And he's from Chile, and it's a Chilean band. And his band was in the training set of Jukebox. And he's got a PhD in computer science and had a lot of money for compute credits on Compute Canada. And he could not, no matter what he did, get Jukebox to make anything that sounded like his band, right? It was just overwhelmed in this noise of like more popular stuff. So one of the projects that he did as a response to this was something called RVAE. Now, this is a generative model. It's nominally a deep learning system, but it's a relatively shallow, simple deep learning system, and it can be trained on just a few dozen examples, right? So we're talking about not all of the examples in Gabriel's own music collection, but actually just a subset of, for him, rhythms that represent the kind of music he wants to make at this moment. If he's performing, he could say, well, in this part of the piece, I want to make rhythms that kind of sound like this. And he uses a VAE model to basically represent this in a two-dimensional latent space, and you can mouse over this and explore the latent space. So it's not doing like autonomous generation, but it's giving him a really interesting control surface to move around the set of sounds that he's picked out and other sounds generated to sound very close to those. All right, so I'll give you a little video demo of this. There's some flashing lights in here, so if you're sensitive to that, maybe close your eyes for a moment. Third finding I'm going to talk about briefly is that one of the reasons I find this data sort of interface, this mode of communication with machines via data as really exciting is that data with machine learning can just be a lot better than math and code for communicating tacit and embodied knowledge to computers, right? If we think about, how does someone teach another person how to play a violin or how to dance or play a sport or any number of other things, we don't sit there and tell people in English or our native language what to do. We don't sit down and write a mathematical equation for how their body parts are supposed to move. Instead, we demonstrate it to them, right? And using machine learning to build any number of the systems that I showed you can just be much more natural because we're communicating using examples. We don't have to translate it all the time. All right, so here's a quote from one of the musicians I worked with at the beginning of this research. She said, "I've never before been able to work with a musical interface that allowed me to really feel the music as I was playing it and developing it." And this was the primary reason for her to use Wekinator in her work. Something I'm really excited about that I'm continuing to go deep on in my research right now is that when people design things with data, we can make the design process more accessible to more people. And there's some examples, some nice examples of this sort of in the popular ML space. If you look at a lot of Google Doodles, for instance, there was one a couple of years ago where you could just kind of click on the screen. It would make you something that sounded like Bach. More recently, there's all these examples using generative AI, where, for instance, you can try to, make a Star Wars trailer as if it had been made by Wes Anderson, which is kind of fun. And there's commercial tools. This appears Lander, which promises you can get instant audio mastering with professional results, right? And so there's a space for this kind of stuff, but a lot of these tools, the promise is that they're going to make it easier for novices to conform to some sort of standard, right? That's not the only thing that we can do. So one of the things I explore a lot in my work is how, if we're designing with data, we can use that to enable more personalization and more flexibility. These are screenshots, or these are photos from a set of workshops I did a long time ago now, CHI 2015, where we were using Wekinator to build musical instruments with people around London who had disabilities. This actually led to a really fun project with the Northamptonshire Musical Inclusion Project, where we built some new software really specifically for music teachers and music therapists who are working with kids and wanted to make musical instruments with those kids. And one of the best outcomes of this research was that at the beginning of the project, they said, "Hey, we want to make musical instruments for kids." And I said, "Great, here's some software. We'll build this for you. We'll make it easy to use." And once we gave it to them in a state that was usable for them to do what they thought they wanted, they ended up doing all this other stuff instead, right? Yes, they made musical instruments. However, they also made a bunch of games where they said, "Oh, I'm going to hide a dog sound somewhere in this space of hand movements, and now you have to find it." They did sort of really, they created these social interactions with each other. And it wasn't about, "Oh, here's an instrument. You don't play violin, but now you can play this." It was like, "Oh, all right, you want to have fun today? Here, I'll put some fart sounds in the interface for you, and you can move around." It turns out kids really like fart sounds. So that for me is a great outcome if you can say, "You know what, I'm not in the privileged position of being the technologist designer anymore. Here's a framework that you can use, and now you can, develop enough proficiency with it that as a non-programmer and non-machine learning expert, you can actually do something totally different." Next, machine learning can help with many tasks that scaffold creative practices. So not the meat of the creative thing necessarily, but the stuff you need to do anyway as a creator. I already mentioned Lander. Music mixing and mastering is viewed by many, not all musicians, but many musicians, as a sort of necessary evil pain point in their work. This allows them to kind of circumvent this and have decent sounding music without doing that themselves. I have a colleague, Phoenix Perry, some of you may know her. She just did a study with our students last year, getting them to feedback on how they were using ChatGPT and other AI systems in their work as creative computing students. And I thought it was really fascinating. They were using it, primarily not to cheat, but to find inspiration, to help refine and articulate their ideas, to translate tutorials and documentation into their native language, to understand coding error messages, right? This is all really powerful stuff. And doing all of this stuff better can help someone doing creative work, right? Let's not underestimate these things. Personally, I get really excited, of course, in enabling people to make fundamentally new types of creative works and creative practices. This is another instrument that somebody made with my software. This is Michelle Nagai's Martlet. This is a piece of tree bark that she found on the side of the road and decided, "I want to turn this into a musical instrument." Why not? Terry Broad is a colleague of mine at UAL, and he's published some papers around what he calls network bending, where you can take neural networks made to generate images and kind of stick your fingers in there and mangle them and get them to do things they weren't designed to do and actually make some pretty cool art. Memo Atkin did his PhD with one of my colleagues and I at Goldsmiths a few years ago. And this is a really lovely piece. This is ancient now. This is 2019. So this is like 400 years ago in machine learning time. But he built this visual, we call it a visual instrument, using an image-to-image model, where on the left, you can just put random stuff in front of your webcam, and on the right, it'll translate it into some sort of images. So this image model has been trained only on seascapes. So no matter what you show it on the left, it's going to have to reinterpret it as a seascape. And this is pretty cool. System actually worked in real time in 2019, which is a big deal. And so you can, put some rocks in there. I'll show you a different model. This one's using fire. He's got one with flowers. Right. So this is, I love this work. And I think the last thing I want to talk about is how machine learning can open up new creative relationships between people and machines, right? The examples I just showed you briefly were about people doing things you just could not do without machine learning. But also, I think there's value in thinking about how can I think differently? How can I be in a different headspace, or just do different things, or think about myself differently when I'm doing creative work? I've got a few more examples to share here. One of my other favorite AI artists is Mario Klingemann. And he was one of the first people to really do a lot of visually impressive work using early generative image neural networks. And this is, again, ancient times now in 2017. He had built himself a system for making AI art. And at this time, you could generate these images fairly easily, but the quality was not necessarily what you're getting now out of things like Midjourney. And he built like a Tinder-like system where he would just generate thousands of images. He says, I produce 1,000 images, and maybe 2 or 3 are great, 50 are promising, the rest are okay, are ugly or repetitive, right? So he has been transformed here into someone who's, in this moment, at least his creative practice is acting more as a curator. Right? He's not saying what should be in an image, but he's using his cultural knowledge and visual intuition to be able to say what is interesting, what is worth keeping. Back to Anna Ridler. These are some more examples from her piece I mentioned earlier. In this blog post, she writes about how she's thinking in this process of making this piece. And she writes, this idea of control is misleading. It's impossible to predict what will come out. I can guess, but I cannot know. The errors and choices that are made up when I'm drawing are amplified, and the GAN holds up a mirror to my own drawing and makes me realize things that I was not aware of. What I find the most important, what I always edit out. It is my work, but also not my work. Recognizably me, but nothing I would have been able to do by myself. Watching it is a very odd sensation, like catching a glimpse of yourself in a mirror before you realize it is you. So I really like her writing on this. One example from my own work here, Letitia Tsunami is another instrument builder who I've worked with for a really long time. I interviewed her once and got her to talk about why she uses machine learning in her work. And she didn't mention actually any of the things I talked about before. She didn't talk about it being easier to work with data or even to make new instruments that wouldn't exist otherwise. She said, in a way, you don't want the instrument to perform like a well-trained animal circus. You kind of want it to be a little wild, and you want to adapt to it somehow, like riding a bull. I think the machine learning allowed more of this fun of exploring instead of going, I have to have a result right away. This thing is going to do that, and leaving it at that. And I find this really compelling. And I think, machine learning isn't the only way to access these kinds of this kind of wildness or surprise. And I think if we're honest with ourselves, if you look at any kind of creative practice, whether with digital tools or analog, there is a relationship between people and the medium and the tools that you're using, and you're not often in absolute complete control. But we have this sort of myth when we think about human creators, at least certain types of creators, as being these like creative geniuses that have this idea in their head, and all they need is the tools to like realize that idea. And the creators I've just shown you are pretty honest about not wanting to work like that, or at least not all the time, that they want this dialogue and this richness of the dialogue. And, one of the nice things about machine learning compared to other digital art creation approaches that involve programming is that often when machine learning doesn't work, it still gives you an image, or it still gives you a sound, or it does a thing. It might give you a thing that's really inspiring and surprising in the way that like a compiler error is not inspiring and surprising. So that's pretty important, right? All right. One last example I want to show you. This is from a recent PhD student's work. He did a study on musicians improvising with AI. He brought a few people into a studio, and he had some software that he was making for his PhD up on the screen and said, hey, I'd like you to just improvise for a while. And they had some basic controls on the screen about, pointing at, what kind of creative direction they wanted the machine to take. And the machine was listening to their audio and kind of responding. And then he interviewed them afterwards. And they had some really powerful things to say, including that they had the freedom to venture places they might not go with a human collaborator, letting themselves be led by a wider variety of cues. One of them talked about playing without prejudice for the collaborator. And another talked about a safe space in which they wouldn't be judged by another musician. Unfortunately for them, there was no AI. It was actually just a guy playing a piano in the next room. And we piped that through the system, and it was a Wizard of Oz kind of setup. And, we were transparent with everybody in the end, and nobody was like super upset, but they were a little bit unhappy because this sort of sense of safety that they had experienced with the AI had been this illusion. And, I think it's kind of a funny example, but actually also points to something really powerful and maybe exciting about AI, that if we don't need AI systems to act like people. And, we don't need to have them, we don't need to believe they have a sense of creative agency themselves. We don't need to believe that, we're approaching the singularity. But actually just the fact that there's something that we're interacting with that is not human can take the pressure off in some ways, or can allow us to be creatively authentic in ways that we might not be ready to do with people. And I think that's a strike in favor of like AI in some contexts, at least. All right. So to summarize what I've said so far, I've talked about how machine learning can help creators work more effectively with data that they care about, enable creators to communicate ideas and intentions to computers more effectively, especially communicating tacit knowledge and embodied practices, can enable more people to become creators, not just conforming to a standard, but actually offering people personalization and flexibility and agency in the design process. Talked about helping with tasks that scaffold creative practices, enabling new types of creative work, and opening up new creative relationships between humans and machines. So I'm going to finish up just giving you a little bit of a tour of some of my current and recent projects. One project that I recently published with Gabriele Vivinsoni about is looking at how we can combine the expressive potential of generative deep learning with the sort of immediate, bespoke, embodied approaches of interactive machine learning, as you've seen in Wekinator. So we've got computational creativity paper looking at how we could stick machine learning into the interaction loop between people and generative models. I've got a really big project at UAL with the Decolonizing Art Institute right now. This is the Transforming Collections project. Super excited about this, and we're about to enter the last year of the project, and there's going to be a bunch of events around this happening at Tate in the autumn. So keep an eye out for that, including some ML workshops focused on cultural heritage. That project, well, in my part of it, at least, we're looking at how machine learning and interactive machine learning can actually help art historians, curators, and archivists to work with their collections more effectively, and in particular, to uncover bias in their collections and make new connections between artists and artworks. So instead of saying, hey, we are tied to, these text descriptions of artworks that were typed into our system maybe decades or even longer ago by people with sort of questionable cultural assumptions, and we're going to do a keyword search over the next 20 years to try to remove anything that might be like objectionable or not PC. Instead of doing that, we're looking at, okay, how can we scaffold something that's a little bit not just more scalable, but more meaningful and allows people to bring a little bit more human intelligence and judgment into it, where they can say, hey, I'm looking for texts that talk about people in these ways, or that talk about artworks in these ways. Here's some examples. Find me stuff in our collections, and then, we'll put this in the pile of stuff to talk about. Or find me images that have things that look like this in it, because I'm curating an exhibition and I recognize the fact that a lot of our artworks in our collection have very little metadata or very few tags associated with those. And I want to find things maybe that haven't been tagged very well because they've been overlooked by museum staff in the past. Very interested in how we can engage creators themselves in collaborative and participatory design processes around future AI. I'm always very interested in, what do creators actually want to do with these tools? Because yeah, some people do want something where they can type in a sentence and like get an image. That's not, it's a useful thing. It's kind of a fun thing sometimes, but that's a very, very limited view. So these are pictures from a workshop that we did with dancers a couple of years ago now, maybe a year and a half ago, examining without computers how dancers imagined wanting to interact with AI in performance. I've been interested for a long time now in how we teach people about machine learning in creative contexts. So I've got an ACM Toast article about this. Unsurprisingly, I don't think it's super useful to teach artists, musicians, designers about machine learning in the same way that you would teach a computer scientist. I think people have different types of knowledge that benefit them, different approaches to teaching. And arguably, maybe computer scientists could benefit from some changes in how we teach machine learning now these days as well. I'm very happy to talk about that, especially since that ties into a project that I've got right now in collaboration with some UCL folks. So Georgina Bourne is a fantastic professor at the Institute for Advanced Studies here at UCL. And she's got an ERC advanced project called Music and Artificial Intelligence, Building Critical Interdisciplinary Studies. And so this is a really fantastic interdisciplinary set of people who are diving into all of the exciting technical changes that we're seeing in music at the moment, right? How machine learning is changing how people are making music, how people are searching and listening to music. But it's, approaching this from a critical standpoint. And my role on the project, which I'm just beginning this winter, really is looking at what does this mean for teaching, right? How can voices from humanities, beyond just sort of AI ethics and responsible AI, how can other voices, other scholarship influence the way that we teach machine learning, both to people in the creative arts and humanities and potentially to people in computer science and engineering? So yeah, this is just down the road from you guys. I'm happy to tell you more about that if you're interested. That is the end of my talk, and I'm very happy to answer any questions.
Thank you. Thank you. Inspiring and fascinating. Do we have questions? Otherwise, I will start with one. Yeah, Nancy.
Sorry. Hi, I'm Nancy. So thank you so much for your talk. I thought it was really interesting because I think I'm someone who's privately always been a little bit skeptical about the use of AI in creative fields. So it's actually really cool to see you show all these examples of how machine learning can be used in a really fun, interesting way. So my question was more about, so obviously one of the issues with one of the advantages of AI is that it helps us very easily to create a lot of unique ideas. But at the same time, that I guess that I think there's also like a risk of people being able to reproduce like a unique idea very rapidly. And so I was wondering what your thoughts were about the potential of AI to sort of very quickly make a unique idea something that becomes very common, and maybe something that makes it difficult to sort of credit like who was the original person who came up with this idea. And so, yeah, what your thoughts were about how we could maybe address that kind of issue with the use of AI in creative fields.
Yeah, so I guess I have two views on that. One of them relates to a slide that I didn't show, but I think I've still got it here. So this is a slide I show in some other talks, but this, on one hand, this ability for AI to actually really quickly make a new thing and then really quickly make a variation of it, and on and on and on, whether we're talking about generative AI or supervised learning for that matter, the iteration time can be really sped up. And from an interaction design standpoint, that can be really exciting, right? And one of the things that I've observed in users of my software, that certainly when I make new machine learning tools now, we really try to design for, is to allow people to take advantage of this affordance to really explore a design space widely, right? And to make lots of prototypes. And yay, what a win compared to at least programming, making things by programming or other really slow processes. So on one hand, like that's really exciting. On the other hand, I think, one of the big challenges, of course, especially in the generative AI space, is nobody has figured out attribution. Whether we're talking, the ethics are thorny and the law is very thorny and sort of underdeveloped. And those things intersect in ways that people are still like trying to figure out. So, I'm absolutely not like an AI legal expert. I'm in general excited about the EU AI Act, which is, progressing through, which at least, requires people to be transparent about copyrighted content that goes into the training of models. So I think, we're making progress there, and like, I'm mainly sitting back and crossing my fingers that people who spend a lot of time in the law and policy space are going to have like some improvements, because the state of things is not great right now, especially for creators who maybe don't use AI at all, but their data is being used in training sets, which I think is a big problem. Yeah.
Yeah, great. Thank you.
Not the application for the room, it's for the people online.
Yeah.
So I've got a question actually from Federico online. The question is, when training a model to support creative practices, which scenarios do you think benefit from using bespoke or personal data compared to a general data set, and which do not? So I guess it was that music thing you talked about, the space.
Yeah. And again, I think it's, it's not an either or, there is sort of a continuum, because there's also a middle point wherein you could take a general purpose model that's been trained on a bunch of, a large set of other people's data, and then you fine tune it on your own data, which is, I don't want to say best of both worlds, because it's also the worst of both worlds sometimes. But yeah, I mean, computationally speaking, of course, we would say that, training on a really big data set is going to be beneficial and even necessary if you're dealing with especially data representations that are quite high dimensional or complex, right? If you're looking at pixels, if you're looking at audio samples, generally, you've got a lot of work to do as a machine learning algorithm to even come to the sort of representation of like, what is a picture that looks like a real thing as opposed to just static. And, I put real thing in quotes because, maybe we don't want reality, maybe we want cartoon faces or something else, right? But, or what is an audio waveform that sounds like a thing that isn't just static, right? So having a lot of data really, really helps us get to that point. But if we're in a different world, like, Gabrielle's example of RVAE, for instance, this isn't a thing that represents audio waveforms. You don't actually need to represent audio waveforms here. What you need to represent is, for kick, hi-hat, and snare instruments, we've got a grid of, I think, 24 different time points. At each time point, is it playing or not? And how loud is it? Or is it playing or not? What's the probability that it's playing? That's another representation, right? That's pretty reasonable. And if you have a set of examples, that's basically just, okay, this is playing, it's not playing, this is playing, it's not playing. You don't need a big data set to learn that pattern pretty effectively. So that's, from a computational standpoint, you can think about it in terms of what's the complexity of the thing you're trying to represent. From an interactive and creative standpoint, of course, that comes back to the stuff that I was starting to talk about here, right? If you want to make music that sounds like Frank Sinatra, this system is actually pretty good, because not only is there a lot of Frank Sinatra in this big training set, but there are a lot of people that kind of sound like Frank Sinatra because they predate him or they postdate him, or they're singing in the same sort of tonal structures as him with the same instruments and so on, right? And so great, you can make nice Frank Sinatra, but if you want to make something that might even be in this training set, but sounds distinct, maybe you'll get lucky and it's possible, and maybe you won't. So it is a really limiting set of tracks that it's putting you on creatively.
Yeah, I had to chuckle because I was reading the story behind Future's Acid tracks back from 1987, and they had, well, if you believe the story, they got themselves one of those what is it, the modulators things, and a Roland TB-303, and had no idea what to do with it, and just started fiddling, and out came an era-defining sound that's still relevant to this day. So sometimes truly novel things can happen. I suppose the interesting thing is whether we'll see something else from these AI, to what extent people are could use these tools to do something truly novel just by playing.
Yes, yeah, and certainly, that's always a dream goal for me in a lot of my research. Can someone use this to make something that sounds new that they really love? And sometimes that happens.
And travels across an ocean and stays many.
Yeah.
I'm not jumping the queue, but I wanted to ask one question. Again, really fascinating work. I'm gonna, in a way, ask you to go beyond the scope of the talk. Did you get any inspiration or ideas that go beyond creative use of AI from this, especially specifically of ML? Because I was thinking about the fact that, like, a lot of the examples that you gave play with this idea of a trade-off between control and instead getting some form of constraint or some form of signal from another source that people can play with. And this obviously, within certain limits, makes a lot of sense within creative. But if you think about other type of applications, medical, as one, obviously then it becomes a lot trickier.
For sure. And that's something that's certainly coming up in this, where's my slide, this Transforming Collections project, right? So this isn't, it's not at the level of medical decision-making. If our model gets something wrong, nobody's going to die, right? However, I'm an art historian. I'm using a machine learning model to try to retrieve items from my collection for review, or, goodness, one of the things we've talked about is, what if this is something the public could use to, like, browse Tate's collection, for instance. There is a definite cost to have something that makes mistakes, and you're generally not going to see mistakes as serendipitous, and they might be annoying, or they might be, inflammatory in this context. So yes, one of the challenges that we have to work with in this project is, okay, we've got people who are not machine learning experts, who are not data science experts, who are experts in some other set of things. How do we give them interfaces with algorithms underneath those interfaces to be able to still usefully engage with this interactive machine learning process, where they say, here's some examples of some things that I'm looking for, or here's some positive examples, here's some negative examples, apply this model to this data set, and maybe I iteratively work with it, right? There's a lot of ways that can go wrong, and it does go wrong because machine learning isn't perfect, and there's all these mismatches between human and machine representations of the world. And Yeah, I mean, as with any of the projects that I've talked about here, you've kind of got these multiple layers that you're trying to address this problem on at once, right? So at the bottom layer, like, how do I make the machine learning stuff the very best it can be? And how do I make the user interface as clear as possible and guide people towards the kinds of corrective actions that are likely to be useful and guide them towards more accurate understandings of the model. And then at the top level, it is also about like, how do I teach users about machine learning to allow them to use this system effectively and responsibly? Because it's not necessarily always something that just happens in the user interface where it's just like, oh, this magically makes sense to me. Like, this is often really complicated and requires people to look at their data in ways that they're not used to and think about workflows that they're not used to. And we always have demos and tutorials and videos and so on. And yeah, there's stuff to address at that level as well, including setting up this expectation that like, this is not an infallible system. It's not intelligent. It's going to make mistakes, and you need to be prepared for that. And here's how we're trying to prepare you for when that happens. And because of that, especially in this context, we're looking at adding provisions for really making data provenance clear, and when things get labeled, who labeled them, and when did that happen? Did the label change? And kind of making a trail, so that down the road, people within an institution can see that. Because yeah, stuff is going to go wrong, and they care about that, and that doesn't necessarily mean the system isn't usable, but we're really, it's a big challenge to feel like we've got a system that in principle works, but it's also something that can be then responsibly used and isn't going to make these really tough social challenges within institutions just like worse. Yeah.
Thank you.
Yeah, thank you for the fascinating talk, and inspiring to see some positive examples of artists engaging with AI. For once, but my question is also about like constraints versus freedom. So I remember in the early days of Midjourney being released, people were very excited to use it for UI designs, like web designers, for example, right? Like creating these really beautiful abstract hero sections. But one thing that became very clear early on is it doesn't have any concept of what navigation should look like, or what information, like without even thinking of things like text and icons, right? So it's beautiful and unusable. Is there a way, is this a problem with the model, or we just need to have a model that's only fed UI examples, or like, is there a way to make it understand what UI designers need?
Yeah, I mean, there's been some really nice work way before Midjourney was a thing. Ranjita Kumar comes to mind to me. I don't know if you're familiar with her work. She's sort of an HCI design machine learning researcher who, 15 years ago at least, was doing some work on scraping the web for web page designs, and then using machine learning to propose new designs and building interactive systems where you could say, well, here's the kind of thing that I'm making. Use this vast data set to try to not make me a website from scratch, but give me a layout template, right? And, I really like that approach. And certainly I'd be very surprised if there weren't people mashing that approach up with the sort of contemporary AI tools where, yeah, at the end of the day, I would say, if you want to make a user interface and navigation flow, gosh, if you're trying to make it learn pixels, that's a lot of extra stuff that you've got to get it to learn. What would I do? Build some really dumb image segmentation and labeling things so that I could, look at existing images or scrape existing websites or videos for a symbolic representation of stuff, and then get a bunch of that symbolic data that really just has the things that we care about, model that. And if you need it to be pixels at the end, then render it as pixels, but not using Midjourney. So, there's a lot of work of that vein. And again, in relation to what I said with the previous question, the better the representation you're using, the less data you need anyway. And the more targeted that data can be to the stuff that you really care about.
Thank you so much for this talk. My question is about how to design for creativity, because you describe a material that's so open, the possibilities are endless. Yet when you showed your Wekinator, was it? It's 10 by 10. It's very simple. There's a lot of obstacles that actually creates a lot of creativity in a way. So how do you balance that scaffolding?
Yeah, I mean, I tend to do that really. I work for that on a project by project basis, where it's, for Wekinator, I was initially working with a very specific set of composers. I wasn't trying to like support creativity by everyone everywhere. I was interested initially just in music, and in this sort of scope of supervised learning. And in even that, I mean, Wekinator itself, it isn't just pixels coming in. You can send any kind of data in principle if you have fewer than about 2,000 dimensions. And you can control anything going out if you have fewer than 2,000 dimensions. But even that, it's a lot of constraint to place on a problem or on a creative domain. That ended up being not just the right amount of constraints, but sort of the right shape of constraints to work with a lot of different musical applications. And then soon after that, as I mentioned, I met someone who's doing interactive game design, and we didn't need to change too much to make it useful for that, but we did need to change a little bit. We added another algorithm for that. But different projects with different user groups feel very different. So I guess what I'm saying is I don't go into my work saying, well, here's all the literature about creativity, and I'm going to choose these definitions for what human creativity is and start with those. Like it's much more user driven with a lot of, formal and especially informal co-design or action research or whatever, in the context, like how do we work together? How do I understand what people want to do? And let's try to prioritize those things and support it. So yeah, I don't have a grand definition of creativity, and yeah, I'm not interested in it. Yeah, thank you.
Yeah. Just mindful of the time. Thank you
Yeah.
so much.
Okay.
Really great.
Thank you.